Okay, so in this video, we're going to be talking about solving trig equations, and we're going to be solving simple trig equations. Okay, so there's two things that you really have to remember here when solving these trig equations. And the first thing is always isolate the trig function. So for example, looking at our first problem here, my goal is to isolate this trig function right here, which is going to be sine theta. Okay, that's always your first step. Also, something to keep in mind. Never divide out a trig function because you could possibly lose a solution. So for example, if you had tangent theta and then you had secant theta and then you had this equal to tangent of theta, well, at first glance, you may say, well, I'll just go ahead and divide out tangent theta because if I do that, this will cancel out here. And then if I divide here, I get 1. And then I get secant theta is equal to 1. However, if you do that, you're actually going to be losing a solution. So the rule of thumb is never divide out these trig functions when you're solving these equations because you could possibly be losing a solution, okay? So with all of that being said, why don't we go ahead and take a look at our first example and talk about how we're going to solve it. So let's go ahead and get rid of all of this here. And we talked about it already, but our first step is to isolate sine theta. We want to isolate that trig function, right? So in order to do that, I have to divide both sides by -2. So I'm going to write here sine theta equal to the square root of 3 all over 2. And it's positive now because I did a negative divided by a negative. As a result, it is now going to be positive. So at this point here, you have your trig function isolated. You have to say to yourself, when will sine theta be the square root of 3 over 2? And this is where you have to refer back to your unit circle. So over here, I have a unit circle that's not filled in. But we know that at pi over 3, the value there for sine is going to be the square root of 3 over 2. So for example, if I put on that angle right here, we know that this is going to be pi over 3. And the values there are going to be a half and the square root of 3 all over 2. Okay? So we know that one of our solutions here is going to be pi over 3. So theta is equal to pi over 3. And then think about it. Sine is also going to be positive in the second quadrant. So that means we're going to have another solution here. Okay. And we know that that's going to be 2 pi over 3. And the values there are going to be -1/2. And then the square root of 3 all over 2. Remember, we know that the y value corresponds with sine and the x value corresponds with cosine. So again, this square root of 3 over 2 corresponds with sine. Same thing here. So we actually have two solutions here. We have theta is equal to pi over 3, and we also have theta is equal to 2 pi all over 3. Now, if you look at what they're asking for, it says solve the equation for the interval 0 to 2 pi. So theta has to be in between 0 and 2 pi. So again, that's 360 degrees. So in this case here, we only have two solutions, okay? Nothing's going to be happening in the third quadrant or the fourth quadrant. And again, I can't keep going around and around here. I'm restricted to 360 degrees. So this right here is going to be your final answer, okay? So why don't we go ahead and try another example? So here's our next example. So our goal here, we want to go ahead and isolate tangent theta. In order to do that, I have to -3 on both sides. When I do that, I get tangent theta is equal to, well, 4 minus 3 is 1. So now you say to yourself, when will tangent theta be equal to 1? And the easy way to do it is first determine what quadrant you're going to be in or what quadrants. We know that tangent is going to be positive in the first quadrant and also in the third quadrant, okay? Please use your unit circle if you have to, but if you have those values out in front of you, you can easily identify this, okay? And so we know that at pi over 4, we're going to have the following values. So if I go ahead and put on my angle right here, I'm going to say pi over 4. And we know the values there are going to be the square root of 2 all over 2. And the same thing, square root of 2 all over 2. And we know that tangent is sine over cosine, or in other words, y over x. So again, this is x, this is y. Well, whenever I divide something by itself, I get 1. So we know here that tangent theta equal to 1, the solution there is going to be pi over 4. But remember, we also have the third quadrant as well. So if I go ahead and put on this angle here, that angular value is going to be 5 pi over 4. So 5 pi over 4. And you're going to have the same values here, except they're going to be negative. You're going to have the negative square root of 2 over 2, comma, the negative square root of 2 over 2. And same thing, when you divide those out, it's going to lead to a positive 1. So you have two solutions here. You're going to say pi over 4, so theta is equal to pi over 4. And also theta is equal to 5 pi over 4. Okay, and this problem is done. Again, you are stopping at 360 degrees. There's nothing else that will occur here for a solution. All right, so we're done. Let's go ahead and box that in. All right, let's try another example. So here's our next example. We want to go ahead and isolate cosine theta. So again, cosine theta is right here. That means I'm going to have to divide both sides by a negative 8. So when I do that, I get cosine theta, right, equal to, well, what ends up happening here? Well, I'm going to divide two negatives, right? So I know it's going to become positive. And then the 4 and the 8, they're going to reduce. So I'm going to be left with the square root of 3 all over 2. Okay? So again, now you say to yourself, when is cosine theta going to be equal to the square root of 3 all over 2? And what I like to do first is determine what quadrants you're going to be in. Okay? Well, I know that cosine is going to be positive in quadrant 1 and also in quadrant 4. Okay? And so again, when will cosine theta be equal to the square root of 3 all over 2? Well, let's go ahead and put in our angular value in quadrant 1, and that's going to be at pi over 6. Right? So pi over 6, and we know that the values there are going to be the square root of 3 all over 2, and then comma, a half. So again, x is pertaining to cosine. So one of our solutions here is going to be pi over 6, because again, this right here is talking about cosine. So I have theta is equal to pi over 6, but then we also have to do the fourth quadrant, right? So if you do the fourth quadrant, what do you end up with? Well, that angle, right, if I draw it in right here, is going to be 11 pi over 6. So 11 pi all over 6. And again, your values are pretty much going to be the same, except your y value now, this half, is going to be negative. But we don't really care about that because we're only looking at that x value. So our other solution here is going to be theta is equal to 11 pi all over 6. Okay, and again, you're solving on this interval going from 0 to 2 pi or 0 to 360 degrees. That's all the solutions that are going to occur here. So let's go ahead and box it in. This one is now done. All right, so we have two more examples. Let's go ahead and check them out. So here's my next example, and this one's a little bit different because now it's asking to find all solutions, right? You're no longer on that interval. You can keep going around the circle over and over and over again. You can even go in the reverse order, right? You can go counterclockwise. So we want to find all solutions, and we'll talk about how you're going to do that. It's not too bad. It's pretty much the same thing, right? But there is one more step you have to do. So the first step, we want to isolate the trig function, meaning I have cotangent theta here. I want to isolate that. I'm going to divide both sides by -9. If I do that, I get the square root of 3 all over 3 equal to cotangent of theta. Okay? And again, it becomes positive because I ended up dividing out two negatives, and then the 3 and the 9, they will in fact reduce. Okay? And so at this point here, you can see that you're dealing with one of the reciprocal trig functions, cotangent theta, right? My recommendation to you, put it in terms of sine, cosine, or tangent. Now, we know that the reciprocal of tangent is going to be cotangent, and we know that the reciprocal of cotangent is going to be tangent. So an easy way to get around this, you're simply going to flip everything. So for example, this now becomes 3 over the square root of 3 equal to tangent theta, right? And so from here, you're going to want to rationalize the denominator, meaning you're going to multiply both the bottom and the top here by the square root of 3. When you do that, you get 3 square root of 3 all over 3 equal to tangent theta, and the 3's will cancel out. So we know that tangent theta is going to be equal to the square root of 3. Now we did this because this right here, okay, and this right here, they're both going to share the same position, all right? Meaning they're both going to have that same angular value. But if I can put it in terms of one of the three basic trig functions, such as sine, cosine, and tangent, it's going to make using my unit circle much easier, okay? So that's my recommendation to you. So now I'm looking at tangent theta equal to the square root of 3 rather than cotangent theta equal to the square root of 3 all over 3, okay? And so now we have to ask ourselves, when will tangent be positive? Because again, I'm dealing with positive square root of 3. Well, that's going to be quadrant 1 and quadrant 3, right? And so when will tangent theta be equal to the square root of 3? Well, that's going to be pi over 3. So if I go ahead and put on that angular value, we'll talk about why that's going to happen. So I know at pi over 3, my values are going to be a half and the square root of 3 all over 2. And we know that tangent is going to be opposite over adjacent, or in other words, sine over cosine, or y over x, right? So if I do y over x here, I get the square root of 3 all over 2, and then divided by 1 over 2, right? Well, think about keep, change, flip. I'm going to keep the first fraction, change it to multiplication, and then flip. You're left with the square root of 3 all over 2 multiplied by 2 over 1. The 2's will cancel. Well, there it is. We get the square root of 3, right? Matching up with what we have here. So one of our angular values is going to be pi over 3. So theta is equal to pi over 3. And we also know this is going to be happening in the third quadrant. That's going to be 4 pi over 3. So for example, if I go ahead and put on that angular value right here, that's going to be 4 pi all over 3. And so on this one here, they want all solutions, meaning I can keep going around and around and around on this unit circle, right? I can go past 360 degrees. So here's my first solution, pi over 3. Think about how you can do this logically. From here to here is going to be 180 degrees, okay? Or in other words, pi. So what I can say here is my solution is going to be theta is equal to pi over 3, that first solution, plus pi, and then I want to include all the other solutions that will occur. Well, if I put an n here, an n meaning any integer, that is going to cover all of my solutions, right? And you can test it out. Remember, an integer is 0, 1, 2, 3, 4, 5, right? It can also be negative. So you could have -1, -2, -3, -4, just no decimals. So if you plug an integer into this n here, you should be landing on either this position here or this position here, okay? And that will work out. So that's how you can cover all solutions, all right? So this one is now done. We can write it just like that, okay? So that solution right there covers all of our solutions. All right, let's try one more example. Okay, so here's our next example, and you can see that we're dealing with another trig reciprocal. This one here being cosecant. So we know that the reciprocal of cosecant is going to be sine, right? So just keep that in mind. Once we isolate cosecant, we're going to want to put it in terms of sine, right, to make it a little bit easier. So our first step here is we have to get rid of this negative a half. In order to do that, I'm going to have to multiply both sides by -2. So I'm going to multiply here both sides by -2. When I do that, I get -2 square root of 2 all over 2 equal to cosecant of theta. Okay? Now what ends up happening here? Well, the 2's will cancel, and I'm left with negative square root of 2 equal to cosecant of theta. Okay? So at this point here, we have cosecant theta isolated, meaning we want to put it in terms of sine, so we're going to have to flip everything. So this negative square root of 2 is now going to become 1 over negative square root of 2. So I'm going to put here 1 over negative square root of 2, and we know that this is going to be equal to sine theta. From here, we want to rationalize the denominator, meaning we're going to multiply both the top and the bottom by the square root of 2. When you do that, you end up with sine theta is equal to negative square root of 2 all over 2. Okay? So now you have to ask yourself, when will sine be negative? Well, that's going to be the third and fourth quadrant. And then, when will you have these values? The negative square root of 2 all over 2. Well, we know that in the third quadrant, it's going to be 5 pi over 4. So I'm going to put here 5 pi all over 4. Because we know, based on the unit circle, our values there are going to be negative square root of 2 all over 2, comma, negative square root of 2 all over 2. Okay? So there's our first solution. That's going to be in the third quadrant. And now we have one in the fourth quadrant, and that angular value is going to be 7 pi over 4. So I'm going to go ahead and put my angular value here, and that's going to be 7 pi over 4. Again, you can use your unit circle if you need to. All right, but those are going to be my two solutions where this value of the negative square root of 2 all over 2 is going to be occurring for sine. Okay, and so now they want it for all solutions though. So how do I do this one? Well, this one here, we're actually going to have to write out two solutions because I can't include both of these positions here in the same solution. It won't work out. All right, so what you have to do here is put theta is equal to, now your first solution is 5 pi over 4. So 5 pi over 4, and to include all solutions, that means if I do 360 degrees in any direction, meaning going either clockwise or counterclockwise, that's going to be 2 pi. So I'm going to put here plus 2 pi, and then again, any integer. So I'm going to put n here, 2 pi n. There's your first solution. Your second solution, you're going to put theta is equal to, well, I have 7 pi over 4. So I'm going to put 7 pi all over 4. And then again, same thing. If I go 360 degrees in any direction, I'm going to land back at this position. So I have to put here plus 2 pi n. Again, where n is any integer. This right here is going to be your final answer. Okay? So that is it. I hope that you gained something from the video. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel. That way you get more math videos in the future. And I'll see you in the next one.